Hello, now I'm going to introduce our MATLAB code and Arduino code. First, we use I2C device and MPU 6050 library to communicate and to let Arduino and G sensor to communicate with each other. And then in the MATLAB code, we use zeros to let computer and Arduino to communicate with each other. First, we open the serial port here, and then send a signal, a character A. And when the Arduino receives the character, it will set the state to 1 and start to record the information from the G sensor, and then send the data by serial port to computer. After the computer gets the serial code, it will take if the difference between two time steps is more than 1,000, we will set that time step as a trigger. It means the time we hit the keyboard, and then we will let the time data be smaller between the trigger minus 10 to triggers plus 500, and then we do the FFT, and then get the angle and magnitude of the result of FFT, and then we will save the results in the CSV file, and then use the Python code, Python keras to train these data. Then after we train the data, we will comment these code and uncomment this, and use the model we have trained to predict the real-time data. And then we will display the output here.
I'm going to introduce about how I train my data on Jupyter Notebook. And the first block is to import the function I need, and then we'll prepare the data, read it from the CSV file here. And I print out the dimension to check if it's 4 dimension, so that I can put into the convolution neural network. Well, I'm going to check if I prepare it in the right way. And now we'll see for 6. The first one is correct, and the second one is also the correct. And now I'm check for 5 for this and this one and this one. Well, okay. Now I'm going to split the data into training set and test set. For this part, I'm going to concate all separate data into one data frame. And this one is to make the label of data. To create model and to store the model. To compile and then train. And now we see how it looks like. Because of our data is not more enough, so the curve may look some weird. Okay. And now we can predict our accuracy for test data. And before I say that it would print out the file for this type. And now you'll see over here. This file means you can see inside a lot of parameters stored after training. And we will import this file inside MATLAB to check for the instant testing accuracy or instant testing results.
And now I'm going to introduce our 3D model of the keyboard. We will put a G sensor here, and the Arduino will be placed here. For each button, we want it has its own vibration frequency, or in other words, we want its vibration frequency more spatial. So we designed a cut in the back of the keyboard here. Okay, and then we can put it into the Cura, and we can use our 3D printer. And here is my 3D printer to make the 3D model of the keyboard. And then after 3 hours, we can get our real 3D model of the keyboard. Okay, let's check if our keyboard can work after this classify process. As you can see, I just pressed the button 8 and the result is also 8.